In 11.4, we're going to start talking about three-dimensional figures. Notice everything we've done up until now have been flat two-dimensional figures. We've been finding area and perimeter and things like that. Well, now we're going to start talking about 3D figures. So that pretty much concludes this section where we really talk about the 3D figures and understanding them and naming them. Now, in subsequent sections, we're going to be going over the area of them, the surface area of them, or the volume of them. So a 3D figure is called, well, not all 3D figures are polyhedron, but we're going to be talking about polyhedrons. And these are solids bounded by polygons. They are called faces. So what happens is, notice this shape here. It's a polygon. It has, or the sides are all polygons. Notice the top looks like a parallelogram or a rectangle. The side is a rectangle. The other side's a rectangle. The bottom is a rectangle. The front is a trapezoid, and the back is a trapezoid. And so notice that every single side has a polygon face on it. The edge, when we're talking about vocab, when we're talking about the edge of a shape, what we're talking about is where the two polygons touch. Where this trapezoid touches this rectangle, this is an edge. So we have lots of edges on these 3D shapes. The edge is a segment that is formed by the intersection of two faces. We also have vertexes or vertices, right? A vertex is an intersection point of three or more edges. And so what happens is, where we have, let's say, this edge, and this edge touch right here at this vertices. So these are like our corners of our pieces. But notice that every time I create a corner, we can identify three edges that touch it. This one, this back one, 2, and this side one, 3. The plural form of the word polyhedron is either polyhedrons with an S or polyhedra for multiple. And so what types of solids might we have? Well, polyhedrons, remember that they're 3D shapes made up of polygons. All the faces have to be polygons. And so this is an example of a polyhedron, and so is this. Notice that in a prism, you happen to have, you'll notice that every single face is a polygon, a two-dimensional polygon. And you'll notice that you have, let's say you make the bottom your base, the top base is parallel to that, and it's equal to it. A pyramid will have also a base, like at the bottom, it'll have polygon faces, but a pyramid will go to a point, okay? So when you have your polyhedrons, you're either going to have prisms or you're going to have pyramids. Now, if you look at the right, these shapes are kind of similar. Notice that this cylinder has a circle base and it has a circle base at the top. A prism and a cylinder are very, very similar in that they have the two bases, they don't go to a point and stuff like that, but a cylinder is not a polyhedron, and the reason is because its base, okay, is a circle. You can't have curves or circles to be a polyhedron, so that's why it's canceled. A circle is not a polygon. Same goes for a cone. If you notice, in a cone, you have a circle base. A circle is not a polygon, and so that's what makes it not a polyhedra. Okay, a cone does go to a point, though, which makes a cone and a pyramid very similar. Okay, the base is a circle versus a square or a triangle, but again, it goes to a point. And so they're similar, yet a cone does not qualify as a polyhedron. And the last one would be a sphere. And again, a sphere has curved edges, and so therefore a sphere is also not a polyhedron. So we're going to start talking about prism. And a lot of what we talk about prisms applies to cylinders. Again, even though a cylinder is not a polyhedron, it has a similarity when it comes time to finding, a cylinder's area or a cylinder's volume. So in this case, a prism, first of all, when we name a prism, we name it using its base. And so what we look at is the base is the part of this prism that there's two of that are parallel to each other. Notice that this prism has this base down here, and the base is a pentagon. And notice there's another pentagonal base at the top that is exactly the same. So since the bases, top and bottom, are pentagons, this is a pentagonal prism. Now, again, the top and bottom that match, those are called your bases. And then the sides that connect those bases, in other words, this side here, these are all considered the lateral faces because they're the faces of this prism that make up the sides. Lateral means side. And if there's 5 sides to a pyramid, you're going to end up having 5 lateral faces. Okay? The altitude or the height of your prism is the distance from the bottom base to the top base. It's the distance of the base, and I represent that height with a little cursive H. It's kind of how I write it. So whatever the distance is from the bottom base to the top base, that's your height or altitude of your prism. These faces hit the base at 90 degrees, okay? So the two bases that are congruent, or let's see, this says the two bases are congruent and they're parallel in parallel planes. And so yes, they're parallel from each other and they are equal. In a pyramid, it's a little bit different. In a pyramid, you have a base as well. It's here at the bottom. The base is going to be some polygon shape. Most of the bases that you're going to see are going to be either a rectangle, a parallelogram, or square, or a triangle. And then you've got your lateral faces. Now again, the pyramid goes to a point known as the vertex. And when you create these lateral faces, you're going to notice that in a pyramid, all the lateral faces are triangles. So you're going to end up, if you have a 4-sided base, you'll have 4 lateral faces, 4 triangles. Now, within this triangle, you're also going to have some interesting parts, right? You're going to have what's known as the altitude or the height of your actual pyramid. That height is going to be this perpendicular line from the vertex down to the center of the base. It's going to hit like that. That's going to be known as your height. It's going to hit in the center of that base, okay? The second type of height that we're going to talk about here happens to be your slant height is what we call it. Now, the slant height might come in a subsequent slide, but I'm going to tell you the slant height is basically from the vertex to the center of the base at 90 degrees. But notice it's kind of sideways. It's slanted. That's why it's called the slant height. And the slant height and the height of your shape, along with this line connecting it, form a right triangle within your pyramid. So as we get to more complex problems, you're going to have to be able to differentiate between the height of a figure and the slant height. Now, the slant height's not here, but the slant height in this problem is known as and written as a cursive L. So again, we've got all these different pieces. So we've got our lateral edges, which are our side edges. We have our lateral faces, which are the triangles. We have our base, our vertex, our height of our whole prism, our pyramid, and then our slant height. So in this slide, it talks about Euler's theorem, which I'll be honest with you, it's not a theorem that we use often. It's here, so I'm going to go over it with you. But it basically says that there's a relationship between the faces, the vertices, and the edges. And by faces, we mean faces including the bases. And so what it says is the faces plus the vertices is equal to the edges plus 2. So in this particular problem, we know that we have, let's say we don't know how many edges there are. Well, we know that there's 6 faces and vertices, if I count them, right, there's 8 of them. So 6 plus 8 equals E plus 2. 14 equals E plus 2. So I know that there's 12 edges on this thing. But again, it's just a relational thing. We don't really do much with it at our level, but that's what the formula is, or the theorem. And then here we go to tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. So again, in this first one, this is a pyramid. And yes, a pyramid is a polyhedron. The name, notice that the bottom or the base is a square, so this is a square pyramid, okay? The base dictates the name of the shape or the polyhedron. When we talk about faces, there's the base at the bottom is one face, and then notice every edge here has a face that goes with it. So there's 4 edges, that means there's 4 more faces. So there's 5 faces total. When we talk about vertices, again, it's where these points are. So there's 4, and then the top one, 5. So there's 5 vertices here. And then edges. Now again, now that I know that I have 5 faces and 5 vertices, I know that equals the edges plus 2. So I know there's 8 edges. So I could just kind of calculate it that way, or I could have just counted. I know there's 4 edges at the bottom, and then every one of these down is another edge, which makes 8. When I go to B, this is not a polyhedron. And the reason it's not a polyhedron is because the bases are not polygons. Notice this has a curved edge. This cannot happen. This cannot exist in a polyhedron. And then I go to the last one, which again, I know this one is a prism. This is definitely a polyhedron. And I look for what the base is. Remember, the base is, there's 2 bases in a prism. And notice that it's a triangle. Notice there's a front triangle and there's this back triangle. So this is a triangular prism. And again, when I start answering the questions with faces, I know that I've got the front triangle and the back triangle. And there's 3 sides to that base, so there's going to be 3 more faces: the back face, the front face, and the bottom face. So I'm going to have a total of 5 faces. On vertices, again, I notice 1, 2, and 3, and then 1, 2, and 3 vertices, so that's 6. Again, now I know my edges using Euler's theorem is going to be 9 edges, but again, I could just count them. I've got 1 edge, 2 edge, 3 edges, 4, 5, 6, 7, 8, and 9. So I can just look at the picture and calculate it, or use Euler's theorem. And then we talk about cross sections, and again, this is where you take this 3D shape and you create a cross section. The cross section is really like a plane, and you think about like as if you were just slicing right through this, and so you would end up with this top piece and then the bottom piece. And when you do your cross section, you notice that you end up getting like a shape of that cross section. So if I was to slice through this pyramid, notice my cross section would be a triangle. So oftentimes we talk about the cross section and identify what type of shape it has. So when you look at here in these pictures, you see that you've got this, looks like a cube. At minimum, it's a rectangular prism. And when you do a cross section, the purple shape is the cross section shape. And you notice that it is a square, or could be a rectangle or a parallelogram. When you have this diagonal here, diagonal cross section, notice that the face is what appears to be like a trapezoid, okay? So you've got like, let's say it's a square or a rectangle, that's the cross section. This one looks like it's a trapezoid. This one here, again, notice you slice it and you're like, the cross section is this triangle here. So some of them are easier to see than others. This cross section, this one's really easy. This is definitely a circle. And then this one, this diagonal cross section, notice that it turns this into a rectangle, or the cross section shape is a rectangle. So most of them are pretty easy to see. Some of them are quite difficult, but the types of questions we might ask you for this is, what is the shape formed by this intersection of the plane and the solid? What is this cross section shape?